Hi, welcome to my short poster presentation about learning hierarchical acquisition functions for Bayesian optimization. So just imagine you want to design such a robotic problem where you want to pour some liquid from a cup into a bin here. So such a problem in general is highly parameterized. So that means we need to define or adjust a lot of parameters to successfully implement such a task. For example, we might require parameters for the trajectory of the cup, and we might need parameters for each controller of each joint from the robot. The general idea is now to learn such parameters. So based on a kind of a reward function, we might to optimize this reward function in with regard to the parameters. So one problem which might occur then is that the parameter space is highly scattered, as you can see here on the right. And if we now try to optimize or to use some optimize method, then we might fail or just get really fast stuck on local optima. So our idea is now to first transform the parameter space into a feature space in which hopefully the reward function is much better suited for our optimization method, so that we find in just a few steps, as here shown, an optimal value. And if we found now this optimal value or these optimal features, then we can make our parameters conditioned onto the features we found as an optimal solution. So what does this mean, or how do we write this in general? So we have here a kind of a reward function, j, which is dependent from the parameter theta. And what we would like now is to maximize this reward function with regard to the parameters and the features. So, and the features conditioned the parameters who controlling or who defining a policy phi. And the policy conditions again the return rt at time t based on the position t and the action ut at time t. And for our reward function, we simply sum up all our return values over all the time span from t0 to grand t. Okay, so that's the general optimization problem which we want to solve. So let's have a look first about the method we are using here. And we are using here for optimization Bayesian optimization. And Bayesian optimization works as follows. So we have some measurement values which are marked here with the black dots. And we have here in small black the real value, the real function value, and we have, based on our measurements from the Bayesian optimization method, we got kind of a estimated function, which is here the solid line. And in addition, we get some variance or some uncertainty value, which is here marked in a gray area. And how does Bayesian optimization now works? We simply make a function which is based on the estimated value, so the solid line, summed up with the possible variance, so that we get kind of an acquisition function which is here marked in green. And what we want now to do is we want to take the best value which promised us the best expected improvement. So in this case, this would be here the green hill here at the top. So what we do then, we just use the parameter we get from here, or the values we get from here, to then evaluate the function again and get a new measurement points as here shown in red. So this is basically the principle of Bayesian optimization. And Bayesian optimization has some nice things. For example, we can it is really fast, so we only need a few rollouts for getting good results. However, this comes with some restrictions. For example, we can only optimize a few parameters. For example, in general, less than 20. And this might be a problem. However, we want to concentrate to get much faster BO results with our hierarchical approach. And how is our hierarchical approach looks like? So the general idea is here. So we have here a system, and the system, just imagine, is, for example, the robot arm, which has to do a certain trajectory, which is also parameterized. So we get from the controller here, which is based on the parameter theta, we get then action inputs u into our system, which then results into some position vectors x, which then goes into our reward or return function, and this value goes then back for our BO or our hierarchical BO. And for the normal BO, we would simply use now the return function or the reward function, give it right back into the BO, then calculate based on our acquisition function the next best or expected improvement value, the parameter setter, and give back then these parameter setters into our controller and then do another run of our system. In our hierarchical BO, we first generate features based on the positions x of our system, and we then first start by finding optimal feature c, and then condition the parameter acquisition function based on the optimal features c, and then calculate the parameter theta, and then give it back to the controller. So how does our approach work, or how do we test it? We tested it on a squat problem. So a simulated person has to make stand-up squats. So it starts here in this position and then try to stand up without falling down. And a successful run was if the person is not or has not fallen down. So, and we tested our approach, our hierarchical BO approach, in comparison to the normal Bayesian optimization approach. And we got the following results. So our hierarchical Bayesian optimization approach is a much faster learner. As you can see here, it only needs basically around 20 episodes, or more or less maybe only 10 episodes here, to get a really good value, which is then nearly constant for the rest of the time. And the normal BO approach requires much more, many more episodes for learning. For example, kind of 25. So it's like the double of episodes required. So basically, what you can see here is that a hierarchical approach enables us to learn much faster these kind of problems. However, here in this scenario, we learned our features from experts. So experts told us which features we have to use. So basically, let me go back here. One important thing or one important feature was the position of the center of mass, here in red marked. And expert told us that this is a really important feature. Also, not also the position at the center of mass, also the velocity of the center of mass was an important feature. So we didn't learn the features. However, in future work, we want to try to learn also features so that we don't need expert knowledge. So thank you for your attention, and I hope you have or you want to discuss this Hybo approach with me in further detail. Thank you.